Nevada Virtual Academy, welcome back. Semester 2, Unit 8, Relations and Functions. As you can see here, you have, a picture from your manual, your book. Page 282 is where everything starts, right? Where the happiness starts. As you move on through the lesson, and I do recommend you guys to use both the online lessons and the manual, which you see right here on the screen. Okay. For this week in Unit 8, we'll talk about relations, as you were able to see in the previous page here. We'll talk about functions. We'll get into the details, dealing with function equations. We'll get back to the absolute value expressions, equations, and in this unit we'll talk about absolute value functions, direct linear variation, quadratic variation, inverse variation, translating functions, right? A lot of material and lots of topics to deal with. I expect you to pay attention in class, do your work, submit the assignments, and everything will be fine. Okay. All right, relations. As you heard in class, a relationship in math, right, will show a pairing between two sets, and that's what we call a relation. Another definition, as you can see in the manual, mapping from a set of inputs to a set of outputs. So we're talking about inputs and outputs, what you put in, what it comes out. Okay. Go over the lesson. You will see in your books examples of problems being solved. We talked about the domain and range of a relation, right? What is the domain? Domain, remember from the class, everything that you put in. The range is whatever comes out, all the possibilities of outputs, whatever your relation produces. Okay. One thing to keep in mind, if you have a relation given to you, as you can see here in example A, as a set made of order pairs, right? Always the first one, the one that comes first, right? Those numbers will make your domain, right? And the second one, and I will change the color here, the y's in this case, right? Or for our algebra class, we know that the second number usually represents y's, right? That would be a range. Domain, what you put in, range, what it comes out. Okay. All right. You will see more examples, how to solve these problems. And then at the end of your lesson, you will have problems to solve, right? Let's see problem number 1. Problem number 1. Display each relation in an arrow diagram, table, and graph. Okay, so you have to go with each one of them and display it in 3 ways, right? You're going to use the diagram, you're going to use the table, and you will graph it. Well, the easy way, one way to start would be to identify, like we did in the previous one, in the previous page, or well, two pages above, right? To identify your domain, and you will circle the first numbers, right? This will make your domain, your input. And if you want to start with the arrow diagram, in the first diagram, you're going to write your numbers: -4, -3, 0, and 1, and actually there's a 3, right? And then you have the second diagram, which obviously represents your range, and for the second one you will put all the second numbers here, right? And actually you can start by saying, okay, for the -4, the corresponding one, the output for that, for my relation, would be -2. For -3, you can use arrows for that. -3, the output will be 1. For 0, the output will be 4. For 1, I have -1. And for 3, I have 3. Okay? And this is one way to display the relation given in problem number 1 by using the arrow diagram. To go for the table, you guys remember our old friend t-table. If you want, you can name the first column x, the second column y, and all you need to do is to plot each one of your points. -4 and -2, right? -3 and 1, 0 and 4, 1 and -1, and 3 and 3. Okay? And now to graph it, you will use a graph and you will plot all these points. And that will do it. Okay? Finding the domain and range. All of these problems from 13 to 22, 23, 24, right? For problem like number 13, easy. Remember, domain always the first number, right? That will make your domain. Range will be the second number. And, purple here, that will make your range. All right. Domain. Problem number 21, right? This is the domain, your x's, and then you'll have your range. The corresponding values for your diagrams here. And if you want, you can see your domain is the set with the elements what? -12, -2, 2, and 12, right? This will make your domain. And the range will be the set with the elements 3 and 4 only. Strange, right? If you want, you can give it, you can write the whole relation as what? Order pairs, right? The first pair, -12 and 3. Second pair, -2 and 3. Third one, 2 and 4. And the last one, 12 and 4. Right? Make sure for the parentheses. Okay, same story if you have a graph. Oops, I move kind of fast here. Alright. If you have a graph that's given to you, you need to identify each one of your points, right? Let's zoom into this number 22 here. Okay, problem number 22. For each point, you're going to identify the x and y. This is -3 and 1, right? This is 1 and 1. This is 4 and 4. This point here will be -4 and 4. Down here we have -4 and -3. And last one, 4 and -3. Okay. Now, to identify your domain, you're looking for all the x's, right? I have 1. Well, let's start with the smallest one, right? -4, -3, 1, and 4. Okay. As you notice here, no number repeats, right? You don't have to write a number twice. And then if you're looking for the range, your range, your y's if you want, your outputs will be the set with what elements? Y goes from -3 to 4, right? So I have -3, I have 1, and then 4. Alright, so this is one way. Another way, as we did in the previous problems, you can write them You can write the whole relation as a set of order pairs. Is your call, but because you need to follow the directions of the problem and make sure that you're doing so. Okay, how about number 23? What is the range? What do you guys notice? The range, when I'm saying the range, is the input, right? I'm looking for x, and x goes from 0 all the way to positive infinity, right? So that will be your, I said range, I said domain, right? Your domain is the x, right? So domain will be the interval from 0 to positive infinity, right? Let me say x will be an element of this this uh, part of your x-axis, and then the range. What do you notice with the range? Y, right? The output goes from 0, including 0, right? Because there is a full dot in there, down to negative infinity. So your range Y will be anything from 0 to negative infinity. Alright, this is one way to answer the question of what is the domain and range for this relation, for this graph. And I hope it makes sense. Okay, you have the diagrams here. You should be okay with that. Okay, how about a word problem from relations, right? Problem number 26. The table shows the number of hours 75 students reported that they had done homework in a certain week. Number of hours, number of students, right? Write a relation as a set of order pairs. Okay, well, this should be easy for all of us, right? How about using x for the first one, y for the second one, or thinking that this is what you have, right? Basically, the first column will represent your domain, the second column your range. And now, this is your relation. First, order pairs. Order pair 2 and 4, right? Next one, 3 and 12. Next one, 4 and 20. Next, 6 and 16. Next, 7 and 12. Next one, 9 and 7. And the last one, 12 and 4. Okay, and this was what part? A, that requires you to write the relation as a set of ordered pairs. Graph the relation in a single quadrant graph. Okay, now for this one we will definitely need a graph, right? We need the two axes, x and y will work. Okay, so you need the y-axis, you need the x-axis, the origin right here, and obviously for B, because this is part B, right? Looking at your x and y, looking at your input, right, domain and range, all of them are positive, so obviously we're going to deal with the first quadrant no matter what. Okay, now check your inputs. The highest number here will be 12, right? So let's put 12 right there. Half of that will be 6, right? How many squares we have? 1, 2, 3, 4, 5. You know what? How about putting 12 here? Okay, so I'm going to use 12 here. 12, and then I have half of that. That will be 6. Half of it will be 3, and here we have 9, right? And we'll deal with each one of them. I have 2, 3, 4, 6, 7, 9, 12. 2. As you can see, it works with we can use the unit squares, I mean the squares here from the grid as units, right? Now on the y-axis it goes all the way to 20. Okay, now you should you know, do your best here to use the whole y-axis. Now if you would go with the same units as on the x-axis, this is not enough, so I have to you know, put my 20 here, and obviously we're going to have a different scale on the y-axis. Makes sense? Because for, you know, for this type, for this length of the my y-axis, if I'm gonna use, you know, the unit squares here, it's not gonna work, right? So that 20 is there. Halfway of 20 will be my 10, right? Obviously, you know, half of 10 here is gonna be 5. Halfway from 10 to 20 is gonna be 15. Okay, now let's plot our points, and I don't know, red will work. Okay, first pair, 2 and 4. 2 and 4. Now this is 5, 4 is going to be here somewhere, right? 2 and 4 will be right there. Okay, this is 2, 2 and 4. Next one, 3 and 12. Well, this is 10, 12 will be most likely here somewhere, right? If I'm going with an horizontal line, from 12 and a vertical line from 3, the next point will be there, right? And if you want, you can label them 2 and 4. This is 3 and 12. All right, next one, 4 and 20. From 4 you go up with a vertical line, and from 20 with an horizontal line, and this will give you the point with the coordinates 4 and 20. What else do I have? For 6, I got 16, right? 16 is about here. Oh, hold on, because the 4 was 4 and 26 and 16. Okay, you can see, go with the vertical line from 6. That will be 6 and 16, right? What's next? 7 and 12. From 7, this is 7, right? You go up to 12. Vertical from 7, the intersection is right there. That's 7 and 12. What else? 9 and 7. Well, 5 is here, plus 2, 7 should be about there, right? Vertical line from my 9, the intersection will be about here, 9, 12. And then I have last point, 12 and 4. 4 is about here, right? From 12 you go up. Well, my pen needs some calibration, but that would be your 12 and 4. Okay, and here we are. We're done with part B. We graph the relation others in a single quadrant graph, quadrant number 1, alright? And this is how you guys should answer a problem like this. Okay, I hope it makes sense. We'll do more in class.